Thank you, everyone, for taking the time to join me today to discuss pulp level control and flotation cells and how Rexa can improve the performance of the dart valves at your plant. My name is Mark Farah. I handle metals and mining industry for Rexa, and I am pleased to have the opportunity to introduce our technology to you. For some of you attending, you may have experience with our products, so parts of this presentation will be a good refresher. For those new and looking to gain a better understanding of our technology, I am confident you will find the webinar to be informative and gain valuable insight on Rexa actuation. So let's begin. As far as the agenda, we're going to talk about Rexa company information. To gain a better understanding of Rexa technology, we'll look at the different types of actuation to distinguish from what we do. It was from the need to combine the benefits of each type of actuation technology that Rexa originates and eventually took shape. We'll review our inner workings of the Rexa actuator and what makes us most unique technology in the market. And we'll look at a focus application, which would be flotation cell dart valve requirements. And we'll look at a pulp level case study of a mine in Arizona, and we'll look at we'll kind of summarize and as far as the advantage and takeaways. So the unique actuator patent and concept and company began as a small startup in the early 80s. After trial and error, the first generation model was installed in a few industries in 1993. In 2008, the X2 generation contained key features that built upon the core technology to make it rugged and reliable. Rex's rapid and consistent growth continues with over 36,000 actuators and drive units sold worldwide. With headquarters near Boston, Massachusetts, and a service and distribution center in Houston, Rexa continues to expand and grow, focusing on key industries such as mining, metals, power, and oil and gas. Rex's global install base has thousands of actuators in the mining industry at major miners around the world. At the Morenci copper mine in Arizona alone, there are over 600 Rexa actuators installed. There are three types of actuator technologies: pneumatically driven, mechanically driven, and hydraulically driven. Each uses a different method to develop forces and create motion, all with advantages and disadvantages. First, pneumatic actuators are most common on control valves on new equipment and projects. Their advantages include low purchase price, and they have fast stroking speeds. However, there are limitations with using pneumatics. Because air is a compressible medium, it needs to build up in order to create motion. The results are losses in resolution, overshoot, or undershoot, and increased dead time. Even with the use of a smart positioner, the compressibility of air is an inherent problem to achieve rapid and accurate positioning. Operating costs are expensive when you include air compressor energy, dust filters, and water separators. In cold weather, moisture in the air lines may freeze and make the pneumatic actuator non-functional. Next is electromechanical actuation, most commonly found in on-off type service, which provides tighter control and better frequency response than pneumatic actuators. They're also good in outdoor service. However, most electromechanical actuators have a limited duty cycle, limited force or torque output, and very few fail-safe options available. The use of electrohydraulic actuators are common to control valves requiring higher thrust and precision. These systems provide fast-acting response, accurate positioning with a high duty cycle. They're also good for high torque applications. These benefits, though, come at a cost. High capital cost, electrical consumption, or oil maintenance costs add up to offset the positioning benefits. HPU units typically have large oil volumes and need routine oil maintenance. Since the hydraulic systems are open-looped, the oil in the reservoir has contact with the environment. Over 80% of hydraulic actuator fails are the result of contaminated oil. Water, oxygen in air, and particulates are examples of foreign matter that degrade the oil quality over time. Many issues with the HPO system can often originate from the breakdown of the hydraulic fluid. Components like servo valves are very sensitive to changes in the hydraulic fluid quality. A complex preventative maintenance PM schedule is needed to maintain the hydraulic fluid's optimal properties. Oil sampling, filter maintenance, oil flushing, and oil replacement must be done regularly to reduce unscheduled failures. So we're going to switch gears and go back to comparing actuator precision. This graph shows the positioning performance of a Rexa actuator versus a pneumatic actuator. The changes to the black line control signal are easily followed by the Rexa in green. But with the pneumatic in red, it cannot respond fast enough and often overshoots the desired set point. With a dead band of 0.1%, which leads to a resolution of 0.1% and a linearity capability of 0.05%, the Rexa X-Pack is the only actuator product line truly capable of matching the potential of modern control systems. I like to use analogies sometimes. They communicate the message or sometimes get lost. The control valve is the final control element in many processes to make copper or gold. Often the limitation of installed actuators is that they do not take advantage of today's advanced DCS systems. One analogy I like to use is the need in Formula One racing to push technology and performance between the powertrain, which includes the engine and transmission, and the racing tire design and compound formulation. As an example, in 2005, at the F1 race in Indianapolis, some tires were failing during the qualifying laps on turn 13. So the tire manufacturer suggested to have the race car slow down for that turn to keep the driver safe but reduce lap times. For a valve actuator assembly controlling liquid flow, we do not need to be limited or slowed down by a pneumatic actuator. With Rexa, the electrolytic performance enables the power of the DCS to be realized. Rexa combines the benefits and capabilities of each of the actuator technologies into one. Simplicity to fail last position and high duty cycle of pneumatics, intermittent operation of electromechanical, and positioning accuracy and fast actuation speeds of hydraulics. Okay, let's talk about some of the benefits of the hydraulic actuator of Rexa. To begin with, it's a very unique design, unlike anything on the market today. The true closed-loop hydraulic system is hermetically sealed with oil volumes approximately 95% less than those found in a standard HPU. Smaller Rexa units have as little as 500 milliliters of oil, which is about 1 can of Coca-Cola soda. There are no filters or oil changes required, making it maintenance friendly. All models can operate at 100% duty cycle if needed through the use of a brushless DC motor or servo motor. These units are high precision and repeatable to 0.1% span. Our modular design allows very high thrust and torque output with a high-speed fail-safe option. Operating temperature range is 40 to 250 F without performance degradation. Having Rexa actuators installed at major steel mines in the world, Rexa actuators are unmatched when it comes to being rugged and reliable. The electronic technology consists of two primary components, the mechanical subassembly and the electrical subassembly. The mechanical portion is attached to the driven device, which in this case would be a dart valve. It contains a motor, pump, flow match valve assembly, cylinder, and feedback housing. The electrical subassembly is basically the positioner of the actuator. This is where the main power supply and control signal are routed, and the origination of 4 to 20 milliamp position feedback for connection to the DCS or other control system. Digital communications such as HART or Foundation Field Bus are also available. We separate the electric and mechanical sub-assemblies for ease of access and operation. There are many severe applications, for example, close to furnaces where onboard electronics simply would not survive. The control box can be mounted in a convenient location next to the valve or up to 700 feet away. Okay, let's next take a look at the hydraulic circuit that Rexa has. This is a real area of differentiation of our technology in comparison to HPU-based electrohydraulic systems. The centerpiece of the electrolytic circuit is our bidirectional gear pump, which is coupled to the DC brushless motor. The gear pump works in conjunction with the flow match valves, which are designated FMV1 and FMV2 on the schematic. It is important to note from a size perspective, the flow match valve and gear pump can be held in the palm of your hand. During operation, when the actuator is at a desired position, the spring-loaded ball checks are locked in place to prevent the flow of oil through the flow match valves. The cylinder is hydraulically locked in place, so forces acting on the valve will not result in valve movement, which is observed in pneumatic actuators. But when there is a signal change, the motor activates, turning the bidirectional gear pump, which instantaneously builds pressure, allowing the ball checks to open. The oil is then transferred through the flow match valve, one side of the cylinder to the other. Once the actuator has reached its desired set point, the motor stops, the ball checks are seated, stopping the flow of oil through the system. When in standby mode, power draw in the electronics cabinet is only 70 watts. Motors are brushless stepper or servo and capable of very high frequency response from 1 to 5 hertz. The cylinders that we use are dual rod or rack and pinion. So the oil volume exiting one side of the cylinder is equal to the volume entering the other side. The design eliminates both the requirement for external reservoir, the need for continuously circulating oil through the system. This also leads us to another significant benefit of our technology, greatly reduced oil volumes. A thin film potentiometer is directly coupled to the cylinder shaft. The cylinder seals are rated for 2 million full strokes or 20 million dither cycles. So let's look now how Rexa actuators can be used in flotation cells. Froth flotation is a process for separating minerals from gangue by taking advantages of differences in their hydrophobicity. This difference between valuable minerals and waste gangue are increased through the use of surfactants and wetting agents. A selective separation of minerals makes processing mixed ores economically feasible. This chart shows the declining copper grades at various mines in Chile. The trend is similar worldwide. Miners must react to the declining ore grades by improving productivity. Because there is really no reasonable alternative technology, future mine expansions will continue to use flotation with increasing cell volume sizes. The flotation process is used for the separation of a large range of sulfides prior to further refinement. Phosphates and coal are also purified by flotation technology. Copper, gold, moly, and platinum are examples of minerals often used by flotation. Two modulating valve applications are dart valve positioning and airflow control. The focus of this webinar will be the dart valve positioning to maintain pulp level set point. Achieving a level pulp will allow the froth layer to be more consistent. To achieve a stable froth level, the actuator should be able to perform flawlessly in the following areas. Actuate at a high duty cycle without stalling, be reliable, not causing unscheduled downtime, be able to position rapidly and accurately to control signal changes. Depending on how the plant operates, be able to fail in place or fail closed. When the dart valve position is near the valve seat, the pulp velocity increases, creating a lower pressure. This force will pull the dart valve toward the valve seat. As cell volumes increase to as big as 600 cubic meters, higher thrust forces and fast stroke speeds are needed. Grade recovery curves are useful tools in weighing the trade-off of producing high grade of concentrate while maintaining a high recovery rate as possible. Two important aspects of froth flotation. These curves are developed empirically based on the individual froth flotation process at a particular plant. The curves are shifted in the positive to the right and positive upward direction, and by doing this, the performance of the froth flotation process is regarded as improving. The theoretical limits are our recovery and percent mineral grade. With 100% recovery, the ore is recovered with little benefit of concentrating the ore. The analogy is throwing the baby out with the bathwater. The other limit is to achieve high mineral grade with infinite time to achieve the separation. The real world is not a test lab with infinite time. So at the Philipsburg mine in South Africa, Rexa actuators successfully replaced pneumatic actuators. We also have an accumulator skid to provide fail-safe. Accumulator fail-closed positioning replaces the spring with the reservoir and piston-type accumulator placed in parallel with the cylinder. This eliminates the need to oversize the cylinder to make up for the force required to compress the spring. The accumulator is isolated from the main hydraulic circuit during normal operation. This control chart was obtained from the end user's final evaluation report at the Philipsburg mine. The valve position is in green. The process variable is blue, is likely the flow rate. There are 3 significant instances where the valve position goes to 0, which is closed due to suction forces. The process variable is impacted and drops. What this would mean is the pulp level in the cell will likely deviate from the set point. After retrofitting with Rexa actuators, because of the stiffness of hydraulics, the valve position never closes. And in this situation, the actuator control strategy was for the 2 actuators was split range. The process variable variation, which was the flow rate, was reduced with Rexa by 43%. So to avoid overshooting, the smart positioner will slowly respond to set point changes. In this picture, with the pneumatic actuator, the froth overflows from the cell lip. We retrofitted with the Rexa actuator, and we do not have the overshoot and to maintain the pulp level. As a retrofit in Arizona, a 2,000 pounds force linear actuator was used with a 6-inch stroke. The fail position was fail last. Sometimes our customers have a difficult time justifying to their management the purchase of a Rexa actuator. It is important to look at all the costs, not only the actuator capital cost, but operating and maintenance cost. Often the Rexa may improve the process to realize a productivity improvement that is only a fraction of the purchase cost. In this case study, the rougher flotation step is followed by the scavenger flotation step that is applied to the rougher tailings. The objective is to recover any of the copper mineral that was not recovered during the roughing stage. Copper contained in the pulp leaving at the bottom of the scavenger cell goes to tailings and is not recovered in the current process. When the end user south of Tucson, Arizona compared the performance of Rexa versus pneumatic actuators, the results were clear. During steady state operation, the copper grade going to the tailings was about 0.15% copper for both types of actuation. But during slurry fluctuations, the Rexa continued to maintain 0.15% copper, while the pneumatic actuators were about 25% higher in copper going to the tailings. The cost to the mine, with about estimated 43 minutes of disruption time per day, is estimated to be about 33,000 pounds of copper that is lost to the tailings due to the pressure fluctuations and the pneumatic actuator not being able to control it. So let's look at operating costs. When looking at operating costs, a single Rexa actuator will operate at under $500 per year versus $7,000 per year for pneumatics. I used the energy consumption costs from the Department of Energy website for my assumptions. The electricity is a significant contributor, as well as compressor maintenance. Replacement dust filters and airline cleaning also contribute to the maintenance component. The Rexa electrical consumption is very low, 70 watts for the electrical cabinet, 120 watts for an intermittent heater, and 800 watts for the motor operated intermittently. This chart shows the annual trend of cost savings using Rexa versus pneumatics. It is comparing 4 units each. The payback from the copper recovery and operating costs is about 9 months. Since sometimes it is difficult to prove recovery savings, this chart includes only the operating costs of the 4 actuators. The payback when only calculating operating costs such as electricity and maintenance is 1.75 years. 4 pneumatic actuators will consume nearly $60,000 in 3.4 years in electricity costs alone, assuming 7.3 cents per kilowatt hour energy cost. This is roughly equal to the amount of electricity that costs to operate Dallas Cowboys Stadium for a football game on Sundays. 4 Rexa actuators would consume less than $4,500 in the same 3.4-year duration. And so the cost of electricity is significant. For some remote mines, the cost of electricity could be as high as 20 cents per kilowatt hour. This is a couple of other installations that I'm going to go through. This is at the Goldcorp Penasquito Gold Mine in Mexico. The Rexa actuators were engineered to satisfy a specific miner requirement. Instead of seating the dart valve by calibrated position, pressure transducers in the cylinder are used. The actuator strokes until calibrated delta pressure is reached and the motor is turned off. A relay tells the DCS the actuator has reached full closed pressure. The actuator adjusts for plug erosion as compared to using a calibrated position. The benefit to the miner is the maintenance interval is extended. Another application for flotation is the airflow going into the cell. These pictures highlight the sensitivity of bubble size and platinum grade. Just with the different sizes of bubbles, there's a 60% grade difference. This is an installation at our Baghdad copper mine in Arizona. Each actuator has a low torque of 2,500 pounds-force per inch, and we have 12 units in their copper flotation area. And this is another installation of airflow control. This is at the Robinson Copper Mine in Nevada. So let's talk about the takeaways. The Rexa has a rapid and precise response of the actuator to position dart valves to keep the pulp level at set point. Hydraulic stiffness allows for positioning close to the valve seat without suction forces to cause the dart to move and close. About a 7-year maintenance intervals are expected as the cylinder should perform to 2 million full strokes and 20 million dither cycles. Due to the fact that the hermetically sealed and pressurized hydraulic circuit is not exposed to the environment causing contamination, the oil never has to be cleaned or changed. With the minimal number of seals and few moving parts, the units are field proven in harsh weather and dusty environments. And much less energy consumption as compared to pneumatics when you consider compressor operation. A Rexa actuator is not a product but a solution that will make the difference for your plant in critical applications such as pulp level control and flotation cells. It's a proven engineering design and an investment that will continue to carry forward. Thank you all for joining in on this webinar today. Please feel free to contact me at any time and I'll be glad to assist you.